An improvement to a recent upper bound for synchronizing words of finite automata. Theory of Automata and Compiler Design. IA-2 C2 Batch Research Paper Presentation by Janhavi Komurlekar and Nabodita Choudhury. Abstract. It has been known since a very long time that any complete discrete end-state automaton admits a reset word of length not exceeding alpha n cube plus O of n cube for some absolute constant alpha. This research paper presents a modification to the latest approach and develop a different counting argument which leads to a more substantial improvement of alpha less than or equal to 0.1654. Introduction. Upper bounds for reset thresholds of synchronizing automata have been a topic of extensive research over the last 50 years. One of the main goals of this research paper is to study the famous conjecture static that RT of A is less than or equal to n-1 the whole square for any synchronizing end-state automaton A. This statement is also known as the Cerny conjecture. Although a lot of progress has been made on this question for the special classes of automata, the general version of the Cerny conjecture still remains. In this research, one of the approaches has been modified to get a more substantial improvement of alpha less than or equal to 0.1654. Modifying the method. A equals Q sigma delta denotes a synchronizing automaton with n states, and we define the co-rank of a word W belonging to sigma asterisk as n minus RKW. In order to make the proposed modifications, the following theorems are used. Theorem 1. Let A and S be subsets of Q satisfying phi does not belong to A or S. Suppose that there is a word W belonging to sigma asterisk such that A does not belong to S and W. Then there exists a word W of length at most n minus mod of A, satisfying either of these conditions shown on the screen. Theorem 2. Let U belong to sigma asterisk be a word of length L and co-rank R belonging to 1 to n by 2 minus 1. Assume that for an integer lambda, there exists a word V of length lambda such that RKV is less than or equal to RKV dash. For any word V dash of length at most lambda plus 2R, then there is a word of length at most L plus lambda plus 2R and co-rank at least R plus 1. Theorem 3. Let U belong to sigma asterisk be a word of length L and co-rank R less than equal to n minus 2. Then there is a word of length at most L plus 1 plus R times R plus 2 divided by 2 and co-rank at least R plus 1.
Methodology. As Theorem 2 suggests, the gaps between the smallest length of words with ranks taking consecutive pairs of words were studies. Lambda of I, the smallest length of a word with co-rank at least I belongs to 0 to n minus 1. We obviously have 0 is equal to lambda 0, which is less than or equal to lambda of n minus 1, which is equal to RT of A. We also write lambda of n is equal to positive infinity and define rho as the smallest co-rank satisfying lambda of rho plus 1 minus lambda of rho is greater than n. Observation. It was observed that lambda of p is less than n square. Further, delta of j is equal to lambda of j plus 1 minus lambda of j for any j belonging to 0 to rho and for any integer r less than or equal to n by 2. Another theorem phi was used here, which is as follows. This is the theorem phi which was used. From the theorems discussed previously, the following corollary was derived. The reset threshold of A does not exist the following value. Using this, the following proposition was made. The proposition is given below. Results. Using all of these theorems and the mentioned corollary, the upper bound for the reset threshold was proved to be given by 0.1654 n cube plus order of 1. This is a notable improvement from the standard value that has been used so far. Conclusion. This research paper used the mentioned theorems and illustrated a method to derive a formula of alpha that is less than 0.1654. This was an improved version of the research conducted by M. Zaikula in 2017. These are the references which were used for the research paper. Thank you.